just reviewed the definition of a base 10. We've created one. Let's move off and actually look at other number systems. So base 10, base 10 is our number system. And that could be our decimal system. That's another way of saying it equals our decimal system. Because each time I move a decimal over, I'm basically moving 10 times in either direction. A good example here would be 2.5. If I were to move the decimal over to the right here, I've moved over 10 times and created a number that's 10 times larger than 2.5. The number would be 25. 2.5 times 10 equals 25. Alright, but why do I use base 10? Basically, we have 10 fingers. It's easy to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Most people have 10 fingers. And that's probably the reason early man created a base 10 numbering system. However, not everybody has 10 fingers. In fact, cartoon characters typically have less than 10 fingers. You'll find many that have 8 fingers. And why do cartoonists actually create cartoons with 8 fingers? Because they need to reduce detail. Cartoons are real simple. But we would call this a base 8 system. The cartoons would use a base 8 system if they counted, and base 8 would actually be an octal system. Therefore, base 10, and I wrote that wrong, so make that a 10. And again, this is our decimal system, but deci, and then base 8 use an octal system, which is, again, meaning 8. We're under base, and change colors, it's getting dark. Under base 10, base 10, our powers, or our place values are powers of 10. Our place values are powers of 10, so my digits are actually 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I'd repeat counting at a different level. And let's take a look at this in a second. Whereas my base 8, the digits, that's actually base 8 is powers, or place values are powers of 8, but my digits here would be maybe 0 through 7. So 0, 1, 2, 3, 4, 5, 6, 7. So for base 10, let's take a look at a number such as 4,316. We'll call this our decimal system. And this actually equals, this would actually equal 4, oh, that looks like a 9. Let me fix it. It'd actually be 4,000. My spelling's a little messed up, guys. This would be 4,000s. I'm going to fix it one more time. I might go to a speller. But 4,000s. Trying to write small. 4,000s. We would have 300s. 110s. And 6 ones. I'm going to scroll the screen down a little bit just so we have a better view. A better or a different, another way to think about this would be, well, 4,000s. Well, thousands in base 10, our decimal system, well, that would be 10 to the third power. 10 to the third power equals 1,000. And our hundreds would be 10 to the second power. This is inside of the base 10 system. So tens, 10 to the first power, and then 1, where the 1's place value, that's in the tens system. The base 10 system would be 10 to the 0, and 10 to the 0, anything to the 0 power equals 1. So inside my thousands, again, I have 4. Inside my hundreds, I have a 3. Inside my tens, I have a 1. And inside my ones, there's a 6. So how do these separate strings reconnect? Well, you end up with, well, how do I get 4,000? It's 4 times 10 to the third. 3 times 10 to the second. 1 times 10 to the first. And finally, 6 times 10 to the 0. And over here in the base 8, this really is place values are powers of 8. The place values are powers of 8. So again, I could take a look at the same number, and again, the digits here, they're 0, 1, 2, 3, 4, 5, 6, 7. But how do I represent a number such as 4,316 in the octal system? Well, this would equal this would equal in the octal system, because remember, these are powers of 8 now. So let's start with our first value, the 6. I'm going to create our chart first. Create the chart first. Now I can begin to look at my base 8 system. Say, okay, well, for starters, we're looking at the ones first. So for starters, what I'm going to say is I have 6 ones. Let's look at the powers of 8. 8 to the 0 power equals 1. 8 to the second power equals 64. a to the third power a to the first power equals 8. A to the second power equals 64. And a to the third power equals 512. Alright, so now you can see that within this number I have 6 ones, I have 1 8, and the 8 is from right here. I've got 3 64s, and then finally I have 4 512. So I have 500. So I have 4 512s, got 3 64s, 1 8, and 6 ones. How do I get to equal this 4,316? Well, it'd be 4 times 8 to the third. 3 times 8 squared. This would be 1 times 8 to the first and 6 times 8 to the 0. And what you do from here is add these together. And what you end up with is, because it's in base 8, it's not going to ring in as a, it's not going to equal 4,316. It's going to be 2,048. And 92 plus 8 plus 6. And that will actually equal 2,254 in the decimal system. So 4,316 in the octal system equals 2,254 in the decimal system.